Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined from Ottawa, Ontario, in Canada by Adrianna Chang, who is a software developer at Shopify. Adrianna Chang, welcome to Maintainable.
Hi, thank you so much for having me.
So I wanted to talk a little bit today about, you wrote an article not too long ago about the Strangler fig pattern, and I want to dive really deep into that. Before we get there, as you reflect on your experience, what do you believe are a few common characteristics and traits of well-maintained software?
Yeah, so I think maintainable software is really about finding that intersection of changeability and ease of understanding. I think a lot of times when we talk about maintainable software, we talk about writing code that's easy to change. But I think sometimes we maybe take it a little bit too far and we sacrifice ease of understanding by maybe creating too many abstractions or creating too many objects. So I think it's really about writing code that is easy to change, but that also reads really nicely and that is easy for someone new coming on to understand. When we talk about clean code, I'm a big believer in the solid principles as being kind of the guiding foundations for what your software should look like. We really encourage them as kind of the principles to follow when writing code at Shopify. And Sandy Metz's Practical Object-Oriented Design in Ruby was one of the very first software books I read, and it really just got me so excited about writing code that is elegant and reads well and withstands the test of time. So it's usually the book I go to when I need a refresher on kind of what those solid principles are and why they're so important. And then scaling up from kind of the class level up to the package level, we talk a lot about package principles and the idea that the classes that you put in your package should be highly cohesive. So the things that change should get together should be packaged together. So kind of a lot of the same concepts as in solid, but moving from talking about like the class level to talking about a group of classes. Our Rails core code base at Shopify is a modular monolith. So we like to talk a lot about modules or components. But of course, it's pretty much impossible to achieve clean software at the package level if your classes don't abide by the solid rules. So those are kind of really like what I like to lean on day to day in terms of guiding me towards clean code. I also think from personal experience, writing code that is self-documenting goes a long way towards writing code that is easy for other people to understand. And it may sound like a simple thing, but I think just having good method names, variable names, class names, breaking up large functions into smaller pieces really just helps others to get a clear idea of what your code is doing when they read it. And then I think the last thing that we've got to talk about when talking about maintainability is good tests for two reasons. The first being that, tests tell the story of the system being tested. They make it obvious, or at least they should make it obvious, what the interface of the system under test is, who its collaborators are. So I think tests really help you to understand the code. And anytime I have to go in and make a change or add a feature to a class, I always like to go in and look at the tests first to get a good idea of what's happening. And then the other side of tests is obviously they allow you to make changes with confidence without fear of regression. So having a good test suite really just allows you to move quickly when writing software. So yeah, I think those are kind of the things I think about when I think about maintainable software.
Great. So I want to dig into a couple of the things that you mentioned there, and just so I understand, because given the audience kind of is programming language agnostic, and I know you primarily work with Ruby and Ruby on Rails at Shopify. I mean, so that's my assumption. Correct me if I'm wrong there. But in terms of when you're using the a terminology around, say, packages, so is that a collection of classes? Can you give me an example of how you in general, if you don't know, everybody listening, that Shopify is an e-commerce platform. People can build up their own shops, and we sell stickers and stuff through that myself. So imagining there's customers, there's products, there's a lot of those kind of inventory things on the public and the customer side of things. Can you give me an example of how you in that context where like maybe a package of classes might come into play?
Yeah, like you said, we are a Ruby on Rails company. That's our tech stack. So our core Rails code base is obviously Ruby on Rails. Rails out of the box obviously doesn't do a lot for modularity. You have your like top level app folder, and then everything pretty much goes in there. So work was done a couple of years ago to componentize Shopify core, which essentially involved kind of splitting up the code base into components, which were like cohesive and holistic pieces of domain logic for our e-commerce platform. So some examples of that might include like online store or capital or shipping. Those are what we refer to as components, and we often kind of describe a component as a package because it is a cohesive part of our system, but packages can be smaller than components, obviously, because a lot of our components are fairly large. And a project my team has actually been working on over the last year that just got open sourced yesterday, actually, is a tool called Packwork. And it is essentially a library that helps you make your Ruby and Rails applications more modular by helping you to define packages and move towards kind of a more modular architecture. And so we've really been pushing people to, extract things into packages within components and those kind of cohesive sections that are probably big enough to serve a purpose together.
So a quick thing, you mentioned pack working there, and I think I saw that get posted on social media yesterday. I haven't had a chance to look at that, so I'll do that and include a link to that in the show notes. I'm really curious about, you mentioned earlier about how important it is to have good, reliable test suite that can run and provide you some confidence. With a larger, Shopify was, I think the code probably started 15 plus years ago, I think, when Tobias started working on it. So are each of those kind of modulars have their own kind of self-contained test suite, or is there still like a one large test suite that has to run the whole stack entirely? Or is there kind of a combination of that?
Yeah, so components do have their own tests. Essentially, a component, it looks like a mini Rails app. Like you have components at the kind of top level, and then within it, you have your app folder and you have your lib and your test suite or whatever. So yeah, the idea is that someone who only cares about a small part of the platform, let's say you're working on online store, you don't care about all the other components. So you should just be able to really go into that folder that is online store, and that is the world you operate in. And those are the tests you work with. In principle, it sounds nice to have boundaries like that, but in reality, they are more kind of just like lines we've drawn in the sand. I know that when Shopify was componentized, the idea was to separate components in order to have like clear areas of ownership, but the boundaries between components weren't very strong. And unfortunately, today, there is still a lot of coupling between components. And that is actually something that Packwork is trying to mediate, is kind of creating clear separation between components, reducing the coupling there, reducing dependencies between components.
Do you use the metaphor technical debt at all in your day-to-day work?
We do. So yeah, technical debt is definitely a part of the vocabulary at Shopify. I think, interestingly, my perspective on technical debt has kind of shifted as I've been on different teams. We can maybe chat about this later, but I've been a part of the dev degree program, which is like a 4-year work integrated learning program where you do 4 years of school, 4 years at Shopify, and you rotate through different teams. So I've actually had the opportunity to be on a number of different teams at Shopify, and tech debt on some of my earlier teams, I think, was very, very typical of what you think of when you think of tech debt. It was kind of this explicit decision to choose an easier solution, knowing it would need to be reworked in the future and that debt would need to be paid off, but making that explicit decision in order to maybe like expedite the release of a feature. And so there was kind of this conscious decision around weighing the trade-offs and this commitment to revisit code in the future to pay off that debt. But since joining the team that I am currently on, which is Code Foundations, I've learned that tech debt isn't always so explicit, and you don't always know that you're kind of incurring it. I think we see a lot in our core Rails monolith, kind of tech debt sneakily growing because bad habits get developed in the code base and people assume it's just the way things have always been done. And there's this need to move fast and to ship features. And there's a lack of knowledge, maybe lack of knowledge of best practices or alternatives. And so we have this like tech debt sneakily accumulating. So I think the onus becomes on our team to educate and empower other developers by, acting as role models with the components we own, letting them know that certain patterns, albeit prominent in our code base, shouldn't be followed, and kind of just like providing the right amount of friction to encourage the right behavior and discourage the wrong behavior.
I'm curious how your teams might approach, maybe because maybe it's different on the different teams that you've worked on there, but in terms of when there is something that's identified and you're like, okay, this is technical debt, this is causing maybe some friction, or like we need to go back and clean this up because we shipped the feature, it seems to be working, but we know that this is going to kind of creep up on us later. How do you go about prioritizing that work as a team? Is that something that you have some to-do list somewhere, or like a backlog of things in an issue tracker, or is it a whiteboard? I'm assuming everybody's working remote at the moment. So like how does that tangibly happen, like get addressed or not?
Yeah, so I think on past teams where the work I was doing was kind of more feature oriented, if we encountered a situation in which we were creating tech debt, we would usually create an issue for it in GitHub. It would get a tech debt label and it would go into our backlog. And then we would maybe plan a week to do kind of some tackling of those tech debty tasks. Or we would also maybe just have someone do like an ATC role for a week and tackle it at the time. On the team I'm currently on, it's a little bit trickier because tech debt is kind of built into our mission statement. I'm on a team called Code Foundations, and our aim is to ensure the health of our Rails code bases, primarily our core monolith, by establishing patterns for good software architecture, and then educating and empowering other developers about good code health. So it's kind of a balance for us between like, okay, do we do the work ourselves or do we figure out a way to teach others to do the work? And I know our team has gotten into some like huge technical debt type projects, like removing stale beta flags, for example, is a project that our team is kind of still wrapping up and it's been ongoing for a year. So it's definitely a challenge to find that balance. And so that's why we've really been trying to develop tools to help other developers understand their code better. We've been trying to tell stories more via blog posts, and we have these internal talks called developer talks where basically give a presentation to all the devs at Shopify. So just taking those approaches to tackling tech debt more and trying to help teams be the stewards of their own code and tackle tech debt in that sense.
That's great that when you have a larger organization like that can invest a lot into their teams to have people that are just thinking about the health and the state of the code base rather than just feeling like their primary mission is on pushing features out. But there's knowing that there's a good balance there. At some point, your team gets like, I don't know how many developers Shopify approximately has these days. Is that a number you have off the top of your head approximately?
6,000 employees maybe, and I want to say maybe
that is a lot of people to try to get on the same page. It's not like, okay, we're just gonna have a quick meeting and we're all doing this from now on, and everybody understands at the same level. It's a very different world than the world I usually live in. So, and I would imagine a lot of listeners probably don't live in that world either. So I'm curious, one of the things you mentioned with the Code Foundations team is you're tracking things and building tools. Do you have metrics that you're using to kind of monitor things to help like indicate? I mean, we know if like a build is failing, but like it's in terms of like things are starting to deviate. Is there anything that you're using to track some metrics there? So you go, oh, there seems to be kind of a dip here somewhere in whatever the decisions you're making on what is of quality code or not.
Yeah, so we do have one tool that we built that is meant to surface information about the quality of a component in Shopify Core. We call it the Component Quality Dashboard. And so essentially it is a dashboard that offers a bunch of different metrics related to the health of a component. We have things in there like the number of errors and information about the breakdown of the test suite, like how many tests are being skipped. We have, I think, kind of one of the most important pieces in there, or the most interesting pieces, is we have this Death Star section. So Death Star is a term I think Sandy Metz coined, but it is essentially a term used to refer to high complexity, high churn classes. And so we built out a little section in there that flags the top Death Stars in a component and kind of assigns them a score, and you can see the score. And we achieved that by building some scripts into a pipeline that essentially like tracks the way files are being touched in GitHub and being changed. And so I think that's kind of an interesting section. You can see kind of if you're trending up or down, if your Death Stars are getting better or worse.
Hi there. Do you know someone who might be looking for assistance with their Ruby on Rails application? Planet Argon would love to meet them. We're offering a $1,000 referral bonus. Send someone our way, and if they sign up for services with Planet Argon, we'll give them a $1,000 discount. And in return, you'll get a check for $1,000 in the mail, just for knowing the right person. Hop on over to planetargon.com/referrals for more information and to refer someone our way. That's planetargon.com/referrals. Thanks.
I want to circle back to one of the first things that I had mentioned about, knowing that you're at Shopify. And one of the reasons I wanted to speak with you is you had written an article, I think earlier this year, and you provide a lot of great visual examples. And it was really helpful. And I've seen my own team share that a number of times amongst themselves as like, oh, this is a better way to explain the Strangler fig pattern, especially in the context of like a Ruby on Rails application, because the Strangler fig pattern is a refactoring approach that I think that comes from the refactoring book by Martin Fowler, if I'm correct. And a number of guests have mentioned it offhand, and I've never really dug into it that much. And I've also noticed that some people will just refer to the Strangler pattern and forget the fig part of it. And so I think it was a couple of guests ago that I was speaking with someone, they mentioned the fig, like that's an important thing that people forget about. It's about a tree, not like someone strangling some code or something. I was like, oh, right. That's probably that doesn't seem so scary. So anyways, could you tell us a little bit more about in what sort of scenarios a Strangler fig pattern might be useful, and especially within the context of Ruby on Rails application, and just kind of like walk us through what that kind of looks like at a high level?
Yeah, absolutely. So yeah, like you mentioned, Strangler fig pattern is the strategy for refactoring code that Martin Fowler described. And the fig part is indeed very important. I remember when I was writing the blog post, I like dropped it a couple times and just called it the Strangler pattern. Comms team was like, no, you got to call it the full thing. Don't call it Strangler pattern. I think telling the story of kind of where the name comes from is also really interesting because it paints a clear picture of what actually happens with the pattern. And it's named after these vines that grow in Australia, and they seed in the branches of trees, and they grow downwards and root in the soil and eventually strangle the host tree and kind of take its shape. So yeah, it's this process where you need to move from a legacy system to a new system, or maybe you just want to like extract a piece of your legacy system into a new system. But using the Strangler fig pattern, you kind of develop your new system and allow it to slowly grow over top of the old system without doing anything destructive. And then at the very end, your old system is still there, but it's strangled, and you can just remove it. So yeah, within the context of the work we've been doing at Shopify, we have this model. It is the shop model. As you can imagine, we are an e-commerce company. So it makes sense that shop is kind of the forefront of our business domain. So shop is a huge class. It's, I think, about 3,000 lines long. It's really gnarly in there. Like there's just so much going on. There's associations, there's callbacks, there's like caching stuff happening. So when I joined Code Foundations last September, I was told that I was going to be working on this project to reduce the size of shop. And we were kind of not entirely sure how we were going to go about that. It seemed really challenging and overwhelming. And shop is so central to Shopify's business. We knew that if we messed anything up, like bad things were going to happen and people were not going to be happy. So we were trying to find this way to do it that felt, safe and not so overwhelming. And so the idea of the Strangler fig pattern got brought up, and we kind of dug into it and talked about like what would it look like to extract a piece of shop out into a different part of the system, a brand new class using this pattern. And that's kind of how we ended up putting together this process for using the Strangler fig pattern. And it's been really useful to us just for performing extractions and breaking up large classes into smaller objects. And I know that when you kind of read documentation about the Strangler fig pattern, it's often referring to like moving from a legacy system over to a new system, but we've really been benefiting from using it just to perform kind of some extractions.
Interesting. I don't, without revealing too much about Shopify's internal business like logic necessarily, but I mean, so for those listening, my assumption as a shop is kind of like is like the company that has their own shop online store, right? So it's kind of like my company, like Maintainable, wanted to sell some stickers. We might sign up for an account, and Maintainable is probably the shop. Is that correct? And then there's like users that are associated to a shop that have access to go in and add and manage inventory and products. Is that a safe assumption?
So you know about as much of the shop as like a lot of people in Shopify. Like the shop model is very kind of ambiguous, and no one is really sure what it is anymore. I think when Shopify first started, a shop was an online store, and it was pretty like easy to see how shop fit into our domain model or kind of business problem. But commerce has evolved a lot, and Shopify's platform has evolved a lot. Now you might have someone who has a shop on Shopify that's not selling a product, or maybe they're only selling in a store and they're not kind of really utilizing the online storefront. They're just using like our POS systems. So now shop is kind of this intersection of like the online storefront, but it's also like the business, but it's also like the merchant who's selling things. So I think that is kind of where a lot of the complexity from shop comes in, is that it no longer is clear what shop is and what shop does. And that just makes it a great candidate for putting more stuff in there. So yes, I digress.
Sure. One thing that I know that we've talked about in other conversations about these topics related to like the concept of a God object. Can you break down what that looks like and like how those kind of become? Is that something that you feel like teams set out like, oh, this is going to become like a really large object, but or you feel like these are things that just kind of organically grow over a period of time?
Yeah, so a God object is usually defined as an object that knows and does too much. In our code base, we often find that the God objects tend to be the classes that were, there from the beginning, kind of a core part of your system's problem space. In our case, it's things like shop, order, product. I think they are the classes that started out with like a clear definition, but as the system evolved, the responsibilities kept growing, and I think they can quickly devolve into these big balls of mud that we like to call them. As it gets harder to define what an object's responsibility is, it gets easier to argue that something belongs in that class, and then it kind of just spirals and more things get added, and your object becomes more of a God object, more of a spaghetti tangled ball of mud.
I had Sandy Metz on earlier this year, and she talked a bit about this as well. Do you have any sort of, you mentioned like the things you're looking at in terms of the health of the code, complexity and churn being examples of that. Do you have other types of hard settings or rules on like how many methods or how long a class can be there, or is that kind of variable still at this point?
I think it's still pretty variable. It's a bit of a challenge sometimes to know when an object crosses into that territory of being a God object. I think we can say with confidence, when a class has a reputation of being really painful to work with, as is the case with Shop, we're like, we know that's a God object. But yeah, we don't really have any kind of hard metrics in place in regards to defining whether something is or is not too big.
Is it safe to assume you're using like a Shopify approved set of like code linters and things like that, style guides that you're able to keep consistent across all your projects?
Yeah, we do have like an internal Ruby style guide, but we don't usually have metrics related to like the size of an object.
Okay. I'm also curious if you're able to share a little bit about what a pull request process might look like there. Are there many people that are reviewing PRs, or is it small teams, or how does that kind of work before things get merged into primary branches and such?
Yeah, for sure. So our kind of pull request and code review process, I think, is pretty typical. When you have a feature you want to ship, you commit your code and you push it. And then in GitHub, usually we have like a 2 reviewer rule. So at least 2 reviews. Oftentimes, my team at least, we are working on components we don't own. So usually we will tag a relevant team as like a code owner review, and then someone from our own team. And then in Shopify core, we merge queue, and all of our like infrastructure and deploy stuff is like built into tooling. So as developers just writing code and shipping features, we don't have to worry about that. When it's ready to get merged, you just click a button and the merge queue takes care of everything. And then we have like a ship it tooling built to handle like deploying and everything. So it's very, very minimal. Kind of thought has to be given on the part of the developer after you've like written the code and the feature is finished, which is really nice.
We'll be back with our interview with Adrianna in just a moment. Hi, it's me, Robby. I want to take a quick moment to say thank you for making time to listen to Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers and or writing a review on Apple Podcasts or Stitcher. Also, do you know someone in our industry who actually is speaking with on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm. And now, back to our interview with Adrianna Chang. There's a lot of documentation and articles and advice on how to submit a pull request that looks and feels a certain way, and like how to review them. I haven't seen a lot of conversations about how to basically take in the responses that you get from your peers. Like, oh, there's some recommended changes. So it's like, what is your take on maybe some good advice for people listening on how to be a good receiver of feedback on your code versus necessarily giving the feedback on someone else's code?
Yeah, I think one of the kind of hard lessons I had to learn is that like the code you write is not an extension of yourself. It is not reflective on your level of intelligence or your value as a person. I remember in the beginning submitting PRs and just like waiting in fear of the onslaught of comments and being like, oh no, people are just gonna tear my work apart. And so I think there's a lot to be said for just like relax, take a step back from the code you've written, and then learn and, take every comment as an opportunity to ask questions. And if something isn't clear, like don't just take a piece of feedback at face value. Like it's okay to say, but why? Or like, can you explain more? Can you provide reasoning? And I think a lot of times that is really beneficial for the reviewer as well, because maybe they have an idea about something that they've had for a really long time, and to have that fresh perspective on writing software as someone who's newer to the industry, I think it can be really helpful to kind of remind them of why they believe a certain thing and how to distill that information in a way that makes sense to folks who maybe haven't been in the industry as long or haven't written code for as long.
Yeah, I think that's some really good advice. We have, interns and junior developers that, that we have in my own company. And I've seen that happen a number of times where they're like, they're nervous about sending over that PR and then when they get the feedback, they're just like, well, I guess I need to do it exactly the way the person said to, or it's like, but also sometimes the challenge can be hopefully that the people providing feedback are doing it in a way that's useful and constructive and not make like you did it wrong. It's like, I think it's helpful for you to, as you were saying, just to kind of reflect this on an extension of you. It's just like, it's a learning process for both parties on teaching both ways, kind of growing, it's also for the benefit of the health of the code itself, which is kind of an independent thing of the other people that are part of that process. So I just don't think enough people talk about like what that process looks like internally in your own like body and mind, and about, I'm intimidated when I contribute to open source projects sometimes too. I'm like, I don't know what I'm doing here, but maybe. And then, I've been doing this for a couple of decades now. So I can only imagine if you're in the earlier part of your career as well, it must be a very intimidating thing to go, all right, can you approve my work? And like, it seems to be working, but maybe here you go. Let me know for sure. So I think that's great. Could you tell me a little bit more about, in our audience, about what Shopify's dev degree program kind of looks like, and like how long is that program, and where's the door for that type of process to get started?
Yeah, absolutely. So the dev degree program is a 4-year work integrated learning program. It is offered by Shopify, and then we have a couple partnering universities. Right now it's Carleton and York in the GTA. And so Carleton is here in Ottawa, Ontario, Canada, for those of you who don't know. So yeah, it's essentially a 4-year program. You're doing kind of the academic side of learning how to write software in the classroom. You're building those foundational computer science concepts. You come out of the 4-year program with a computer science degree, which is really nice. But then you also have the practical hands-on aspect of getting to write, code to solve real problems and getting to ship code into production and build things as a part of a team on the Shopify side. And I think that's really where you kind of learn the key elements of like, what does it mean to work in a team? What does it mean to write and review other people's code? What does it mean to ship code to production? All those kinds of things. So yeah, it's this 4-year program. You come out of it with a degree and 4 years of experience at Shopify. You get to be on a bunch of different teams as a part of the program. So you really get kind of a holistic view of like what software development can look like. And you're allowed to, decide what part of software you want to be in, whether that's mobile or front-end development or back-end or data science. So yeah, I just came out of the program in April, actually. Started in the first cohort and have recently graduated.
That's awesome. Well, congratulations on that. And that's great that Shopify has programs like that they're working with universities and doing that. And I've always been a big admirer of the initiatives that Shopify seem to be doing there. So that's awesome. I'd be really curious, like kind of following up on the pull request topic that we were just digging into. Do you find that a lot of the challenges that teams have when it comes to dealing with the older monolith at Shopify and the code, that sometimes it's more about the communication and the team level type of issues? Are these more about, or do you feel like it's purely mostly just technical related issues? But do you feel like there's another aspect to it that's kind of more layered in just how the teams are organized and how much knowledge information gets shared across teams and how effective that can be?
Yeah, so I know we like to say at Shopify that like the application structure of our Rails code base is not a reflection of like organization-wise what teams look like, and like we have teams working on different elements of the code base and collaborating in that way. But I do think that a lot of the time context kind of gets embedded into the software in a way that's not obvious. And I know, like, for our team, I've mentioned before, we work on a lot of core, but we don't build features for core. And so kind of our knowledge of the business context is not super strong. And so I think when we have to go in and make a change, a lot of the time it's not obvious kind of why the system was designed in a certain way, or maybe there's like unclear or ambiguous language used. And as someone who's coming in without all that context, it can be hard to understand. And I imagine people who are like onboarding into that part of the code base are experiencing similar things where it's just like, I don't understand what's going on here. And I think sometimes that results in like going down rabbit holes of like, let me get blame and figure out who wrote this and let me go try and find context in that way. And I will admit that a lot of core is not like super well documented. Like we don't have, obvious tech design docs related to parts of the system. So
It's interesting. I know that they sometimes you mentioned earlier that code should be fairly self-documenting, and I think a lot of times we're like, it's a good variable names, method names, things like that nature, and those are things that very much are kind of baked into the ethos of the Ruby community. I think has always been something we've always kind of aimed for as a fellow Rubyist myself, and then. But when it comes to talking about like when you look at like a git blame, sometimes it's like a lot of like, here's we made this change. And then you're like, okay, what does that link back to? And you might have to go back and look at through some old project management tools or whatever the tools you're using there over the years to track down how things get changed. But sometimes those, you mentioned like design docs or certain anything that kind of explains why decisions were made that way. Why was it implemented that way? Not how does it work? Because usually code can be you can kind of walk through and kind of get a good sense of this is how this thing kind of works together. When I do this, it calls this and this happens. Okay, I can't to some degree get an idea of the work order that's happening in this process, but why was it built this way is sometimes missing, and that can be a really challenging thing when you're joining in an existing team. And I know that maybe just another thing I was curious about, given that you're going through the dev degree program, and I'm not exactly sure what your background is with computer science classes or anything, but a lot of times developers will come in and think, they've learned how to build some new things, but then when you dive into these bigger existing applications, most people don't start their career off with like, okay, brand new application, here we go. It's usually someone's already built out something and you're like, oh, well, that's a whole different sort of environment. How has that transition been for you to go, oh, like how long did it feel like until you got comfortable with the idea that you were working on something that was way larger than you would have been able to build by yourself in a period of time?
Yeah, I mean, in a way, I was fortunate because when I started kind of formally learning computer science in the academic setting of university, like I was already also at Shopify and getting to learn what it looked like to work on existing systems. And in a way, it's almost less scary to work on existing systems because you're like, oh, everything is already in place. I don't have to think about how this whole thing fits together the same way you would have to if you were like building something from scratch, like I had to do for some school projects. But I think you learn kind of the importance of having things like tests and tooling in place. I remember in school, tests were always just like the thing you added at the end because you knew you had to have them to get the marks for your assignment. And you were like, okay, I've written the code and now I write the tests and I submit my assignment and I never have to think about it again. But you really learned that in working in a system that is constantly evolving and changing, like it's so important to have those things in place. And the reality is like the code you're going to write, it is going to change. Having tests in place and really putting care into the code you write pays off in the long run in a way that maybe isn't so obvious when you're just building like a one-off thing that you never really have to think about again.
Excellent. Well, Adrianna, I really appreciate you digging into talking about things like, introducing our audience or maybe even reintroducing them to, and maybe a familiar topic for them in the past, but the Strangler Fig pattern in particular and sharing a little bit of behind the scenes of how things are going at Shopify and how the teams organize and manage their work and how they're breaking up things. And definitely would also include a link to Packwork in the show notes for people that are curious about it. And with that, where can listeners best follow your thoughts on software development online?
So I am on Twitter at Adrianna Chang. You can follow me there. I will also just quickly shout out Shopify's engineering blog. I'm hoping to continue contributing there. So you might hear from me there, but a couple of people on my team have actually written some really great posts there. We have a post there about Packwork that you should read. And also one of my colleagues just wrote a blog post about the current state of our monolith, I think called Under Deconstruction, the state of Shopify's monolith or something like that. So definitely check out the engineering blog if you haven't already to hear more from me and the work my team is doing.
Excellent. Well, it's been such a delight having you on Maintainable, Adrianna. Thank you so much for joining and talking shop.
Thanks for the chat, Robby.
Maintainable.